This video covers Chapter 11 of our textbook, how to implement the design that you've come up with that we covered in Chapter 10. So at the end of this section, you should understand some of the DDL commands you need to create databases and tables, and also how to create constraints. So all of the SQL we have used up until now has been part of data manipulation language, or DML. This chapter introduces data definition language, or DDL. You use DDL to define the structure of a database. So typically these tasks are done by a DBA, database administrator. However, it's not a bad idea for you to understand them. You may want to create small databases for testing. All of these actions can be accomplished with the SQL Server Management Studio. However, some relational database management systems may not have a graphical tool, and you will have to use DDL statements. The create table statement creates tables based on column definitions, column attributes, and table attributes. Null or not null identifies whether a field can contain null values. The default is null. Primary key identifies the primary key for the table. When you identify a column as the primary key, two of the column's attributes are changed automatically. First, the column is forced to be not null. Second, the column is forced to contain a unique value for each row. In addition, a clustered index is automatically created based on the column, and we'll talk a little bit more about that later in this video. Identity defines a column as an identity column, which is a unique integer value. This value is generated by incrementing the previous value for the column. SQL Server allows only one identity column per table. Default specifies a default value for a column. This value is used if another value is not specified. And sparse optimizes the storage of null values for a column. It is used if you have a lot of null values in a column. So let's take a look at some examples. So if you wanted to create a database, you could use the create database command. And notice after I do that, I have a go command, which is a script command, that actually executes this before I go to use it, and subsequently I'm going to want to create some tables. So I'm going to create this database. And now I'm going to create some tables. So this first create table example is just creating a couple of columns or fields, and only the data types, not really any of the other characteristics of the field. So we'll use this new database that we just created, and we're going to create a new table called vendors with two fields in it. So this next one, we're going to create a table called invoices, and in addition to the data types, we're going to define the column attributes. So this invoice ID is a primary key, it's an identity column. The vendor ID is an integer data type, and it does not allow nulls. Invoice date can be null. Invoice total is a money data type, and it has a default value of 0. I wanted to create another table called vendor sparse, and we know that the second field or second address is often not populated with any values. It's often null. We can specify it as sparse, and that will increase the efficiency of the database a little bit. Okay, so we've created a database and we've created some tables. Let's take a look now at some indexes. So an index provides a way for SQL Server to locate information more quickly. When it uses an index, SQL Server can go directly to a row rather than having to search through all the rows until it finds the ones you want. An index can be either clustered or non-clustered. Each table can have one clustered index and up to 249 non-clustered indexes. By default, SQL Server creates a clustered index for the primary key. Indexes speed performance when searching and joining tables. However, they cannot be used in search conditions that use the like operator that starts with a wildcard. And they cannot be used in search conditions that include functions or expressions. Because indexes must be updated each time you add, update, or delete a row, you should not create more indexes than you need. With a clustered index, the rows are stored physically on the disk in the same order as the index. Therefore, there can only be one clustered index per table. With the clustered index, there's a second list that has pointers to the physical rows. You can have many non-clustered indexes, although each new index will increase the time it takes to write new records. It is generally faster to read from a clustered index if you want to get back all the columns. You do not have to go first to the index and then to the table. And again, writing to a table with a clustered index can be slower if there is a need to rearrange the data. So when to create an index? Good idea is when the column is a foreign key, when the column is used frequently in search conditions or joins, when the column contains a large number of distinct values, and when the column is updated infrequently. Remember that SQL Server creates a clustered index automatically for the primary key, but you could change it. Usually, the primary key is the best column for the clustered index. Oh, and there's one feature that some of you may have found in SQL Server Management Studio. It's called a snippet picker, which is a great name. You can insert a snippet of starter code by right-clicking in the query editor window and selecting the Insert Snippet command. You still have to modify it to make it relevant for your purposes. So we'll take a look at that right now. So here I am in SQL Server, and if I right mouse click, I have this insert snippet option, and I determine, well, what kind of, what do I want to insert? Let's say I'm going to say index, and I'll say, well, what kind of, give me some subcategories. So I'll say, well, create a index basic, and it'll pump in the code for me, and then I can modify it to make it more relevant. And one thing to keep in mind, I had a student do this last quarter, is you can create your own little snippet. So if you see yourself kind of writing the same code over and over again, you might want to create a snippet that just does it for you. Okay. Constraints. So constraints are used to enforce the integrity of the data in a table by defining rules about the values that can be stored in the columns of the table. Constraints can be at the column level if they apply to one column, or table level if they apply to more than one column. Constraints are tested before a new row is added to a table or an existing row is updated. If the new or modified row meets all of the constraints, the operation succeeds. Otherwise, an error occurs and the operation fails. So here's some examples of column level constraints. And there are also some table level constraints. Again, table level constraints apply to more than one column. Let's take a look. Oh, we kind of sped up over indexes. Let's take a look at indexes too. So we're going to use that database we've already created. We can create a new index. And this is just creating an index on one field. I need to create the table first. Hold on. Okay, I've created an index on one field in the invoices table, vendor ID field. And in this one, I've created an index on the invoices table, and I've created on two fields, invoice date and invoice total. And notice on invoice date, I've put it in descending order so that the most recent date is going to come up first. And you can also create indexes on just subsets of a table. We'll also notice that we're prefixing the index with an IX. This is a good practice. Come up with some naming convention so you can quickly identify the indexes. So here we're going to create an index on the invoices table where the payment date is null, so they haven't paid us yet. Okay, we've got some issue there. Well, we're going to power it through here. So we create filtered indexes on just portions of the database. This is a good thing to do if you've got large databases and you think you might need to just get a portion of the database to satisfy some of the queries. So here we are in constraints. We're going to create a table with a primary key, a composite primary key of invoice ID and invoice sequence. And we can also create check constraints. So in this case, if the invoice total has to be greater than or equal to 0, and the payment total has to be greater than or equal to 0. So we create a new table called invoices 1. So this is two column constraints. Two column check constraints. This is a table constraint because we're combining both constraints in one. So we'll create a table called invoices 2 that has the same two constraints but just in one statement. We'll create a new table invoices 3 and then we'll check the constraint. So invoice total has to be greater than 0. If we try to insert into that table an invoice where the invoice total is less than 0, we will get an error. So when you create the constraints, it's a good idea to actually test them. Make sure that they do what you think they're supposed to do. Here's one interesting. We're going to create a table that constrains the input, the vendor code, to character A through Z, first one, A through Z, second one, 0 to 9, the third character, and just numbers the last 4 characters. And the first characters of the vendor code match the first characters of the vendor name. So if we try and test that, we see that this first one actually matches the first check, but they don't match the vendor name and the vendor code, so that's going to fail. Okay, and the way you create foreign key, typically the foreign key constraint refers to the primary key of the related table, and this helps you maintain referential integrity in the database. So here we're going to create a table called vendors 9 with the primary key of vendor ID, and now I'm going to say another invoices 9, another table, as a foreign key that references that primary key in the other one. Okay.